Alright guys, so we're still in section 2.2 and the topic is going to be lines. So you may recall this as y equals mx plus b, but we'll get to that in a second. So before, when we had an equation, it would look something like this. 2x plus 4 is equal to 11. And now we're talking about equations that look like this. Y is equal to 2x plus 4. So what's the difference between these two guys? Well, you'll notice that the first equation only has one variable and the second equation has two variables. So with the first one, remember that we're talking about finding a solution. What number times 2 plus 4 is equal to 11? That's essentially what the first equation says. Number 2 says we're not just trying to find a solution. This is talking about a relationship. It's the relationship of how does y relate to numbers that you plug in for x. Okay, so typically we're going to isolate y, but like in the first equation we would isolate x, but generally from here on out we're probably going to isolate for y. So what we say is x is the independent variable, y is the dependent variable. So the idea basically boils down to you choose a number for x, and see what y becomes. So for instance, if we had an equation with x and y on the same side, this kind of becomes a little trickery. We say, well, what number for x and what number for y do we need to pick so that they add to 3? Well, this is kind of like trying to figure out this question without doing algebra. 2x plus 6 equals to 21. If we don't do algebra here, it's essentially just a guessing game. So the same is true here. If we don't isolate y, it's really hard to figure out what numbers work here. So now, since we're talking about lines, right, and all of these things are a relationship between x and y, we have three forms. Standard form. Well, there's probably more forms, but these are the ones we're going to talk about here. These are the most important ones. We have standard form. Ax plus by is equal to c. A, b, and c are just numbers, and x and y are variables, right? Okay, you have slope intercept form. So that looks something like this. Y equals mx plus b, right? M is slope. B is the y-intercept. And that's essentially where the name comes from, slope intercept form. And once again, x and y are just variables. Then you have point slope form. And that looks like this. Y minus y1 is equal to m times x minus x1. where x and y once again are variables. M is slope once again. And x1, y1 is an ordered pair or a point on a graph. So how are these all the same thing, right? These formulas kind of look considerably different, right? But I'm telling you they're all lines. Well, they're all lines because it basically boils down to the relationship of y and x. It's y equals something, right? But if the power of x is 1, no matter what numbers you add to the left and right, it's always going to generally be some sort of line. It could be going in the other direction, but graphically, it's going to be some sort of line. And it's mostly because of the power of x when related to y. Okay? So let's see. So how are we going to use these ideas? Well, if they give us 2 points, we need to find the slope. And so how do we do that? Well, we do that with the slope formula. Which is y2 minus y1 over x2 minus x1. And that's equal to m. And so all this is basically telling you is if you had the picture of a graph, right, and you had a point here, and you had another point here, this is the point x2, x2, y2, and this is the point x1, y1. And so really all you're doing is taking the y's, right, and subtracting them from each other. So you're taking this y and subtracting it from that. So essentially you're bringing this y down to here. And then you're subtracting this x from this x. So you're essentially moving the point back here. And so you're seeing how much is the point going down and how much is the point going to the left. Or, you know, you could think of it as how much are we going to the right and then up. And really what you're calculating is this, right? The steepness of the difference between the points, and that is the slope. Slope is just another word for steepness. Okay. So how do we find the slope? If we're given 2 points, well, we use the slope formula. Okay. So what if we are given a slope and 1 point? How do we find the equation of a line? Well, it's in the name of one of the forms that we talked about. We have a slope. They're going to give us a slope, and they're going to give us a point. So which one of the forms we talked about has both the word slope and point in it? Well, point slope form. And just to rewrite that again for you guys, y minus y1 is equal to m times x minus x1. So for an example, let the slope be -3, and we want the line passing through 4, 8. And so we have our equation. We know the slope is -3, so we can just plug that in there. And since this is a point, right, and points are x, y's, we know x1 is 4 and y1 is 8. And we can just basically plug in those numbers for our placeholders. So we'll get y minus y1 is equal to m times x minus x1. And by plugging in the values that we have y1 is 8, m is negative 3 times x minus 4, because x1 is 4. We simplify, y minus 8 is equal to negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. Then we add 8 on both sides, because remember, we're always trying to isolate for y when we have two variables. And so we're going to get y is equal to negative 3x plus 20. And you can tell that this is now in y equals mx plus b form. But this is the equation of our line. Okay. Let us do one more example and then we'll wrap this video up. Okay, so what if instead we're given 2 points and they want us to find the equation of a line? All right, so in the previous case, we were given 1 point and the slope. But if we're only given 2 points, we have to do one extra step. So for an example, let's say they tell us to find the line going through 3, 4 and 0, negative 3. So, well, if it helps, we can kind of graph this out really quickly. One, 2, 3, 4, something like that. That's the point 3, 4, 0, negative 3. That's the point right here. 0, negative 3. And so we're trying to find the line that goes through both these points, right? So you'll have to excuse my drawing here, but something like that, right? We're trying to find the equation of this line. But in both of the equations for a line that we have, I mean, we have technically 3 equations for a line, but really only 2 useful ones. Typically, you won't use standard form for very much. We have point slope, right? We have point slope form. Y minus y1, which is the one we just used in the last one, x minus x1. Okay, and then we have slope intercept. Okay, so for slope intercept, we need the slope and we need the y-intercept. And for point slope, we need the slope and a point, right? The point x1, y1. And so do we have either of those here? No, all we have is the points 3, 4, and 0, negative 3. Well, remember with our slope formula, we can find the slope using these 2 points. And so we have the point 3, 4 and 0, negative 3. So using the slope formula, we have m is equal to y2 minus y1 over x2 minus x1. And so it doesn't matter which one you call x1, x2, or sorry, x1, y1, or x2, y2, as long as you keep them straight. So if we call this one y2, then we'll have negative 3 minus y1, which is 4. And so x2 is 0 minus x1, which is 3. So negative 3 minus 4 is negative 7. And 0 minus 3 is negative 3, and so a negative over negative is positive. So our slope is 7/3. And so now we have a slope, right? And we have 2 points. But notice for point slope form, we just need slope and 1 point. So we can choose either this point or this point and plug it in to get the equation of the line. So I'm going to choose the 3 and 4 for no particular reason. So y minus y1, which is 4, is equal to m, which is, we figured out is 7/3 times x minus x1, which is 3. And now we can do algebra distribute. So we have y minus 4 is equal to 7/3 times x. 7/3 times negative 3. The 3's are going to cancel out because this 3 is on the bottom and this 3 is on the top. So we get negative 7. And now we're going to add 4 to both sides. And we get y is equal to 7/3x minus 3. And that becomes the equation of our line. So, conclusion. What do we need to find the equation of a line? Well, at the minimum, we need 1 point and slope. So, what if we were only given 2 points, right? So assume they give us 2 points like they did in this problem. What do we need to do? We need to use the slope formula, because the slope formula requires 2 points. We use the slope formula to find the slope and then use either one of the points that we got that they gave us originally and plug it into point slope form. So to try to draw a little diagram, a very poor one, but if you have 1 point and slope, you use point slope form, and that gives you the equation of a line. And so what if you have 2 points? Well, then you use slope formula, excuse me, and that will give you the slope. And then take this slope and one of these points, right? We have 2 points, so I'll call it A and B. No, I don't want to write it like that because that looks like an ordered pair. So take the slope here and 1 point, and then you're back here, right? So once you find the slope using the slope formula, you basically follow this chain now. So the longest problem that they can kind of give you is just giving you 2 points and making you find the slope so that you can use point slope form having 1 point in the slope. Hopefully that makes sense, and we'll cut the video there.